So I'm Weston Pace. I'm going to be talking to you about DataFusion without row groups. And I'm a engineer at LanceDB. I worked in the past on Apache Arrow and Substrate. Lately, I'm working on Lance, which is a lakehouse format. We've got a file format, a table format, catalog format. And I've personally spent a lot of time just focused on how do we get data out of object storage quickly. And I'm semi-local, which is good because I'm not really going to be pitching LanceDB too heavily in this talk. I'm mostly just going to be talking about my own personal vendetta. So let's go ahead and get started. First, I should explain real quickly what row groups are, because probably not everyone spends all day looking at the insides of files. If you have a bunch of data in a table, there's kind of three classic ways you can store it. You can store it row major, row, column major, and row groups. I think most people are probably familiar with the first two, having worked with arrays before. Row groups is basically saying, I'm going to take the first 1,000 rows, and then I'm going to store each column. And then I'll take the next 1,000 rows, and I'll store each column. This is kind of what's used inside Parquet. It's used inside of Orc. It's very common, and I think it's flawed. So I am a bit of a broken record. I wrote about this like 2 years ago now. Then a bunch of new file formats came out, and they all do row groups. I'll give Vortex some credit. They do row groups by default, but you can configure a way out of it if you want to. So I have to keep going on the warpath and explaining why row groups are a problem, and also why you guys care, mainly as like DataFusion query engine users. And my general thesis, and if you really think this is not a vendetta, I should say I've had this shirt for like 6 months now. Row groups considered harmful, like GoTo, they're not inherently bad. I like to think of it like Lucky Charms in my house. In theory, it's part of a balanced breakfast. In reality, I find my son at midnight eating all of the marshmallows. So problem with row groups is if they exist, query engine developers will use them to do bad things. As soon as I start talking about this, I get the army of buts. But this, but that, but that. So for the rest of this talk, I'm going to be explaining why these things are not really a problem and you can get away from it. So first one is but my spatial locality. And we have to ask, what is spatial locality? So, I should also mention that PAX was in one of the previous slides. There was a bunch of like academic names for all these things. Instead of like row major or column major, they say NSM and DSM. And the code name for row groups is PAX. And so this is a slide from one of Andy Pavlov's lectures, basically saying the whole reason we're doing this is we get the benefit of faster processing on columnar storage. If you're a DataFusion user, hopefully you know that columnar storage and columnar in-memory layouts are all great. You get a lot of vectorized processing. And you get to retain the spatial locality benefits of row storage. I should mention that I respect Andy Pavlov a lot, and he's done a lot of great things, but there is no such thing as spatial locality. In fact, it's not very well defined. So I watched the talk, and in the presentation that's accompanying that slide, he says data that's related to a single tuple or row will be close together. So the idea is here, if you have a row and you wanted to actually grab that whole row, it's really efficient. They're all right next to each other. You can grab it with one IO operation. As soon as we move to column, like a column major format, suddenly your values for a single row are very far apart. So the hope is with row groups, our values for a single row are close enough that if we do have to grab the entire row, we can do it fairly efficiently. Unfortunately, we have to look at the hard realities of storage and what the real world is actually like, especially if we think about cloud storage. I like to think about these two values, speed and mover. MVR, minimum viable read. If you read too little, you're just throwing away effort. So people say, oh, don't read 50 bytes from a file. You might as well read 4 kilobytes or 20 kilobytes or whatever, because otherwise the overhead is killing you. So you get some stuff for free in a sense. That's why we can say if these things are all close together, let's just do one IOP. Even if there's a little hole in the middle, that's fine. And there's also seek penalty drop off. This is a point where you want to make things big. When we talk about columnar storage and we talk about reading from files, we want to do big sequential reads. At a certain point, it's big enough. Like there's no real benefit to making things bigger. So this is like if you have like 30 megabytes of data and you're going to read that versus reading 15 megabytes here and 15 megabytes there, you're going to have more or less the same amount of time because you're spending so much time pulling out data. The little seek that you have to do in between is negligible. Or to put it another way, if we want to make this whole spatial locality thing work, we have to say that, well, we want these things to be so close together that they're less than this minimum viable read. That it's like we might as well just read them both. That hole is so small, let's just grab them both. But when we look at how big we make our column chunks, we want to make them at least SPD. And the reason we want to do this is because the most common, not the most common, but lots and lots and lots of queries, we're only going to grab like one column or two columns. And if you're just reading one column, you're going to grab this block, and then you're going to skip through all of that, and then you're going to grab this block, and then you skip through all of that, and you're going to grab this block. So if these column chunks are not big enough, then you're doing a bunch of really small random reads, and that's bad. So these need to be bigger than SPD, and these two green dots need to be smaller than MVR, and as long as that happens, we win. The reality is that never happens in any kind of storage whatsoever. On cloud storage, you want column chunks that are 1 to 8 megabytes. Your minimum viable read is about 32 kilobytes, so you're not even close. 1,000, like 256 times away. On an actual like spinning disk, it's more or less the same picture. NVMe, they're kind of the same. It's maybe a little, you have to be really good for this to actually be 4 kilobytes. In practice, it's usually a little bit larger. But it's not smaller, which is the point. And so this whole spatial locality thing, gone. It doesn't exist. So I went back and I read the paper that introduced PACS and said maybe they had a different definition. And they did. And it's sort of useless for us. The original paper said every query engine in the world is going to process data in rows. There's no such thing as a columnar query engine. That's a bizarre concept. Oh, there is this one weird one, but every other real one is going to do rows. So the first thing you do when you read your data in is you have to transpose it so you can send it into the query engine. So the whole point of the thing that row groups are based on was saying we need to feed data to row-based query engines. Well, if you're here for a DataFusion talk, that's not your problem. So once again, no such thing as spatial locality. So who cares? You know, it's still kind of cool. It works. It does, you know, we can solve that mover speeding problem. Problem is I've already lied to you with this picture. It's very nice and clean and pretty, and we have all these nice sized chunks. The reality is columns are not the same width. So if you look at an actual file, you have something like this, where you have maybe a numeric column, very narrow. 1,000 numbers is 4 kilobytes. 1,000 strings, it depends. If we're talking about websites, we could be talking about megabytes worth of data. And so what happens is your column chunks are almost always either too small, they're less than the SPD value that we want, or they're really big. And getting much bigger than SPD is okay, it's not so bad. If you're going to err on the side of anything, just do one row group for your whole file, and you're generally going to be fine, except you're going to break a lot of things, and we'll get to that. So looking at this in reality, this file right here is from the FindWeb data set. It's this website that a lot of our users, data set that a lot of our users use to train LLMs and things like that. Here's a Parquet file. We have row groups. Here's row group 1, row group 2, row group 3, row group 4. It's keeping all these columns together. The problem is these URL column chunks, 17 megabytes a piece. Really big, much bigger than speed. That's good. We're good. This is good on cloud storage. These fetch status chunks, 0.1 kilobytes a piece. So this means that now if I want to satisfy this query, select star from URL fetch status is greater than 299, I need to do 16 IOPS because I have to read 1, 2, 3, 4, 5, 6, 7, 8. And they're not close together. I can't, you know, mesh them together. They're not close together because there's this big green block and yellow block in between them. So it's 16 different reads to satisfy that query. So is there a better way? There is an excellent way. I just made this up the other day. In Lance, we use Rex, really excellent data layout. And it's a very simple concept. It's like, why, I still want to do column chunks. I still don't want to have to buffer all my data in memory before I write it. But there's really no need to dump a whole column chunk worth of fetch status when I only have 0.1 kilobytes. So I'll just keep accumulating that one. And I end up with a different number of column chunks per column. And it all works out. Like we built this. And now when I want to run that query before, instead of 16 reads, I'm doing 10 reads. So in our experience, we're pretty much always like struggling to get the most out of object storage, and that's about making sure we're doing lots and lots and lots of large reads. So now our scan is like 20% faster than it was before. Now, I did skip over this whole thing that says you can actually read this in a very efficient way. That's a much longer talk. You'll just have to assume that's possible. But my partitioning. When I talk about partitioning, I talk about this nice concept that we have a file and we want to process it in several different batches on several different machines. Row groups work really great for this, it seems. We've got 3 row groups. We've got 3 cores. We can go and we can run this thing in parallel. What could possibly go wrong? Oh, well, now I have 7 cores. So row groups are a struggle for partitioning because, well, now we don't have enough. So it was like, oh, okay, well, I'll just get more row groups. Well, that means you have to rewrite your file. And what happens is the number of cores, the number of query units that you want, the amount that you want to parallelize this is a read time decision. Your row group size is a write time decision. So having to make read time decisions at write time is a recipe for lots of rewrites. But it's okay, you know, we'll figure it out. Oh, wait, there's another problem. Now I'm applying a filter. I'm going to skip the first 2 row groups. I only get a little bit out of row group 2. Maybe that's enough data. I could actually parallelize it, but I've chosen to parallelize on row groups. Now I'm, again, just wasting cores. That's okay, but oh, wait, now there's another problem. If we start looking at like how big is an actual batch when we process it, that's going to be very query dependent. So I shouldn't say a lot of people. This is just like us at Acero a long time ago. We used row group as our like batch size. And that became a big problem because the ideal batch size, we want to pick something that kind of matches our CPU caches. And that's going to be very query dependent. If I'm just grabbing URLs, maybe I can get thousands and thousands of rows and I can still fit it within that cache. If I'm going to be processing imaging content, well, now I probably can't grab that many rows and still fit it within cache. And I should mention at LanceDB, one of the big things that we're trying to do is make a database that works well across many different types of data. So large strings, numbers, images, video. We have to solve these kinds of problems. And so using row groups in any way for our unit of compute is a bad idea. Surely no one would actually do that, right? No one's using row groups for units of parallelism or compute. Well, here's DuckDB's documentation on Parquet. DuckDB can only parallelize over row groups. So if you have a single giant row group, that's bad. It's only going to be processed by a single thread. Then they go on to say, but wait, if you have really tiny row groups, that's bad too. So you get to everyone's favorite thing about row groups is that they turn into this really fun optimization tuning problem where you're having to like, if I go too far to the right, I'm going to blow up my query. If I go too far to the left, I'm going to blow up my query. I have to hit that sweet spot in the middle, but oh, that sweet spot in the middle is query dependent. It's maybe going to change from query to query, but I have to decide that spot when I write my data, and it causes a lot of headaches. And the basic idea of why it's so hard is you're making storage decisions and compute decisions, and you're coupling them together. This is the whole problem with row groups is they're an okay solution to this storage problem that we talked about, you know, trying to make sure you have these large column things, but you're not blowing up memory. But they're a bad solution to just about every other problem that people keep trying to couple to them. All right, so how do you do partitioning without it? Once again, that's like a whole other 15-minute discussion. The short answer is you make a file format that can support random access. And then at read time, you can pick whatever batch size you want. I want 1,000 rows per batch. So you say, okay, well, this thing will get 0 to 1,000. This next core will get 1,000 to 2,000. Next core gets 2,000 to 3,000. And because there's no overread or read amplification, you can just go with that. And the next query, maybe you want 10,000. Again, there's no read amplification, so you can just go with that. Anyway, random access is a whole nother talk, but again, I often get like, why do you hate Parquet? Anytime you want to work on a file format, everyone's going to ask you this question. I don't really. Rex can be yours if you love Parquet. It's a one-line change to the standard. Just say a column may have multiple column chunks in a row group. So if anyone wants to go out there and spend a lot of time on making Parquet fix this problem, that would be pretty cool. All right, last thing, but my statistics. We all love row group statistics. We can store the min and the max for every single row group, and then we can go through and we can skip all the data that we don't need based on our filter. That's pretty cool. But then people already said, well, that's too coarse-grained, so let's put statistics in the pages, which are these little things that are inside of row groups. Because row groups are so big and we need statistics at a finer level, And then other people came back and they're saying, well, actually, that's way too selective. Unless your filter is a certain kind, you actually really want row groups. And then other people came and they said, well, actually, even putting them in the row groups is too selective. We need to do like really fast decisions based on a file level. So in Iceberg, we're going to store the min and the max for every single file. So we don't have to like open the file to look at it. And it's basically not that simple of a problem. And in fact, there's this whole paper that was published a little while ago where they said, even if you're putting it at the page level, that's maybe too coarse grained, because the ideal, like ideally for this one particular query, you'd want stats every 100 rows. But for compression, you want your pages to have at least 10,000 rows. So even if you're trying to couple your stats to pages, it doesn't work very well. And then at LanceDB, we're looking at all these other kinds of statistics, like bitmap statistics, geostatistics, vectors, sorry, indexes. Now, same idea. Statistics are just a type of index. We're looking at all these other indexes that don't even map to the files that well. It's very orthogonal to the way your data is ordered. It's becoming a very big problem. If you're going to try to come up with one like file format or figure this all out in advance, it's a problem. And the main thing that we ran into and decided is just indexes in the file are a bad idea. This is a table format problem. And the reason that is because people change their indexes in a database all the time. They learn something, they say, oh, now I'm going to start querying this column. I actually want this column to be indexed in a particular way, so I'm going to go and add an index in it. Well, if I told you that if you want to add that index in, you now have to go and rewrite all of your data. A lot of our customers who have images and videos, like 600 petabytes of data, and you tell them to go rewrite their data so that they can make a B-tree index on this column, they're going to give you a very strange look. And a lot of this is originating from a problem with cloud storage, which is you can't modify a file. You can only replace the file outright. And that's why table formats, you get more files, and now you get more flexibility, because if you have a table format, you have a bunch of files, now you can replace your index files without changing your data files. So you get back that ability to model parts of your data set without having to change, or sorry, modify parts of your data set without changing your whole data set. The downside, of course, is more files, more flexibility. You need to get a table format. There's some great ones out there. So it's not too bad. I used to say, this is like a TV show called Dodgeball when I was in high school or whatever. It's like, if you can dodge a wrench, you can dodge a ball. If you can write a file, you can write a directory of files. It's, every file system supports that. It's not too bad. All right, so in summary, columns must be broken up in some way. Packs is an anti-pattern, leads to all these poor query engine behaviors, hurts your performance. Rex is an alternative layout. And this is all just lining up my pun at the end, which is Pax is dead, long live the king. Thank you.